Hey everyone, welcome to the latest episode of Factory Reset Podcast. Today we have Eric from SK International, who we've been working with for a while now as part of our entry into the US. So before we jump in, Eric would love to get you to introduce yourself, a little bit about your background, how you got into automation, and how what SK International does as well.
Yeah, sure. Thanks for having me on, Rahul. Yeah, a little bit about my background. Actually, I'm a journeyman tool and die maker. So I did an apprenticeship, basically running CNC mills, specialty grinding equipment, and then building and trying out stamping tooling throughout United States, Canada, and Mexico. One of our suppliers at our company was SK International. They were a design supplier for us and supplying some manufactured components for us. And at some point, I got pretty close with the owner of SK. And in my mid 20s, he said, "Hey, I have a shop in India. Are you interested in coming over and taking a look at what we're doing and trying to help us out a little bit?" And I said, "Sure." So my first trip to India was 2018. I sort of fell in love with the company, and the timing worked out a little. Unfortunately, my family had to close down our tool and die business in 2019, but we really started ramping up with SK around the same time. So it was like an immediate jump feet first into SK and trying to grow our manufacturing capabilities in the United States, to kind of diversify, and put ourselves in a position. So SK is not just an importer, but we're also able to manufacture and support our tooling here in the United States. So from humble beginnings with that, we've kind of grown into a pretty good sized manufacturing operation here in the U.S. Full welding, fabricating, machining, turnkey controls, robotics, AMRs. So we've come quite a long way from where we started with, doing engineering changes for Indian tooling that was being imported. And I was always kind of a gearhead. I was always into race cars and off-road trucks and things like that. So it was like, oh, we're going to assemble a cylinder head. Okay, I've done that manually, but now we're going to automate it. All right, this makes sense to me. So coming in, it was like falling in love all over again with the new industry and automation and things like that. And I think that with the true rise of Industry 4.0, especially with AI coming into the picture, and with there's a big push for robotics right now, especially, we just had a union negotiation a couple years ago. There's a lot of talk about how to maybe replace some expensive labor with robotics as the boomer generation sort of starts retiring out of the United States assembly plants, but also humanoids, also AMRs instead of fork trucks. And then we have another union contract coming up, and there's talks, mandates of, N thousands of robots to be deployed throughout the United States automakers over the next 5 years. So I think between SK and Botsync, we're sort of uniquely positioned to, get our market share of this push. So
Amazing. I think, like you pointed out, there's a lot of hype around robotics in general, especially with humanoids and physical AI. Everyone's really looking at robotics in a lot more attention than what they did maybe a decade ago. But I think what we've experienced as well is generally implementing automation successfully is not just about the robots. It's about how everything comes together, the integration with the existing ecosystem. But apart from that, the people and the processes that the company already has. So from your perspective and your experience so far, why do you think the automation hype focuses purely on the robots when there are so many things behind it? And where have you seen real implementations fail or not perform as expected when the integration with the ecosystem around it doesn't really go well or is not prioritized from an end customer's perspective?
sure, yeah. So if you look through the automotive lens, automotive assembly plants have been using robots, forever. So often when you're doing an automation application for something in that space, it's not like you're reinventing how to assemble the transmission. They're basically saying, "Hey, we've done it this way 10 times in a row. We're just looking for a price to do it again," right? So in those applications, typically the successes are very high. It's there's not a lot of room for creativity. You're designing from a reference often, and you know it's going to work because we did it 2 years ago and it worked 2 years ago and it worked 4 years ago. So you're sort of just either accommodating maybe a model year change or introducing a new product onto the existing line. So those applications, it's not, it's pretty confident that it's going to work, right? On the EV side, the BEVs and the plug-in hybrids and things like that, there's some new applications in there now that maybe haven't been done before. There's some other factors involved like magnetism and static electricity and some of these really fine laser welding applications where, okay, it's been done, but maybe it's only been done a couple times and it wasn't the same process for each time, because not every battery manufacturer, not every drive unit manufacturer is doing it the same. There's a lot of change in those. So those, there's a little more room for creativity, but still you're working into a volume that is high enough where you got to have a rock solid, robust, reliable process. And usually those applications go pretty well. Where we've seen challenges over the last few years is the non-automotive guys, the industrial products, the commercial products. The CEOs of these companies are basically putting a lot of pressure on their people to say, hey, we want automation too. Why can't we do the same thing? So we have a few customers in the industrial product space where, in automotive, they may have, if you're talking like an engine, they might have like 20 to 30 SKUs of engine models or whatever. In these industrial product spaces, some of these guys have like millions of SKUs that they could produce, especially on like the sheet metal side. Maybe they're press braking, I'll use like gym equipment. So depending on if it's a Planet Fitness or, Anytime Fitness, it could be the profile of the structure is the same, but the powder coat color is different. Or you could have a 1,000 different types of profile shapes and sizes and lengths and whatever. And often these are mom and pop size businesses who are getting kind of gobbled up by private equity, and then private equity is pushing to automate. So there's no standard from plant to plant to plant to plant. They started out as 4 totally different companies. They're trying to standardize where they can. But what we've seen is it's kind of, I won't say bad word, but it's kind of like crap in, crap out. So if you're trying to automate something and the parts that are coming in are not in tolerance, not consistent, even if they are, or sometimes they have tolerance ranges that are, plus or minus a quarter inch. And then you want to, robotically weld it or move it around into a fixture with a AMR or something into a precise location. There's added layers of complexity there, right? And then kind of to go along with that, the back end push from these, everyone kind of follows automotive, right? But this back end push, now they're trying to put AMRs into facilities where maybe the concrete floor is not smooth. It's been a fabrication company for 50 years and the floor is, totally beat up. So the expectation is the AMR is not going to get stuck in a rut somewhere in the floor, but how are we supposed to plan for each and every little rut in the floor, right? So there's definitely some challenges we've been facing with some of these guys lately that have led to some failures and sort of changed our when we go in and we pitch these solutions to people, there's a different level of, hey, we got to be realistic with what your facility is capable of, and not only that, what your people are capable of. If you only have a maintenance guy who's, making sure the hydraulic system's running on your stamping press, and now you want to put in a vision guided robot system on an AMR, you're going to have a hard time supporting that equipment. So there's a little bit of reality checks that have to be given out to these customers sometimes on what makes sense.
Got it. I think that's an interesting point. I believe we had a couple of sessions as well where we spoke about standardization not being standardization being an important element to ensure automation is successful. And when it is not the case, it becomes a fairly difficult and expensive process to automate, which generally doesn't get the results which the company or the owner wants to achieve for. So I think on the basis, you mentioned a few points, right? You mentioned flooring conditions, you mentioned tolerances in machines and what is being tolerance of the parts and what's being handled, and the variations of SKUs. And I think the other one you mentioned is about uh, the capacity and the talents pool that the company has. Apart from these specific conditions, have you seen other challenges which you think companies need to be aware of when they decide to automate or not?
Yeah, one other thing, some of these companies, right? Like, let's say uh, you have a plant that's in St. Louis and you want to put some automation in, and even
Hmm.
if it's a Fanuc or whoever, you're going to get support in that area from Fanuc, from Keyence, from Moto Man, whoever it is. Like, all these big companies have resources in the areas, but if somebody has a plant that's out in the middle of a cornfield in Iowa, you're going to have to fly somebody in. So the cost of service is not being considered very often. And when something goes down, even from a warranty standpoint for us, right, we have to make sure that we're planning, hey, if this goes down and you need to call us out, it's not like going to a major city and having access to everything you need to support the system. There's a lot of challenges where these more rural plants are getting pushed, and there's no local support for those guys. So that's been a
Hmm.
big thing that we've been taking into consideration for some of these customers as well. So
Got it. Very interesting. Yeah, that's a great point, actually. I think a lot of people they discount the service cost, the cost of ownership. So things like spare parts, the replacement cost, getting that fixed down the line, and the downtime if something goes down, if the machine's down. I think important factors to consider. I mean, I think you mentioned a few points about existing facilities and how flooring conditions or other infrastructure can become a bottleneck for automation to be successful. On that basis, do you see more successful greenfield projects, or do you see a lot of brownfield projects where automation does have a fair advantage to offer for customers?
yeah, I mean, if I say take the industry out of it, right? Then a
Hmm.
greenfield project, you got a blank slate. You can make sure you have enough room for aisleways for the AMRs to come down, turn around, come back through, pass by each other. That human AMR distance, safe operating distance, is able to be like easily taken into consideration up front.
Got it. I think that's interesting. So, I mean, we did this study before where we kind of scouted out what projects happen in a year, and it seems like you said, greenfield projects have a lot to offer in terms of flexibility to design. But the number of greenfield projects that happen is very few compared to brownfield projects because of the amount of capital investment required. If you could walk us through, like, as SK International, you mentioned you have a fairly large engineering capability internally, from where design tooling all the way to kind of designing robotic systems. So how do you approach as a company when you start working with the brownfield implementation from like the solution stage all the way to implementation stage? What does that journey look like for an end customer and for you?
Sure. Yeah, let me actually give a good example of two
Hmm.
sides of this, okay? So we we worked on a weld cell, and it was for one of our big customers, and it was a full turnkey integration, um, auto flex fixture, two MIG welding robots, and a material handler robot with grinding in the cell. So it was a
Hmm.
complete deployment, brownfield site, and we went in. We had good support from engineering. The plant engineering was pretty good. We had good plant engineering support. And then I was the launch manager for this tool. And while we're there, the this is one of those 1 million SKU number type situations as well, where the
Right.
parts coming in weren't exactly to tolerance. But the we were replacing a booth that was a manual weld booth where they had manually welded these products for the last 50 years or whatever, and next door to our auto cell was still a manual cell because there were some like very low runner SKUs, maybe like 1 to 2 a year, that they had a bunch of those. They were just going to do them manually. And so the leader of the manual weld line was ultimately responsible for the man who was going to be running the auto line that we put in. And
Hmm.
he pulled me to the side and said, "Look, I understand corporate wants this fancy technology, but I'm just letting you know, and I'll deny till I die. I will do everything I can to make sure this piece of equipment never goes online. Okay. And I'm like, wow, okay. So I I'm not gonna go tattletale. I'm trying to make it work and work with engineering and whatever. And engineering basically said, I kind of asked, oh, who do I need to, basically tell me whether I'm getting a good assembly out of the cell or not? And they said, oh, it's that guy over there. Same guy. Every part that came off of that line, bad part, bad part. So was it a bad part? The way they qualified was with a tape measure. So it's a little subjective to who's using the tape measure. If you're getting down, they were down to like a 32nd of an inch, like less than a millimeter with a tape measure. So I don't know. It was close, right? So the runoff didn't go well. They wouldn't sign the papers and whatever. And the project sat in limbo for a little while. So another division of the same company raised their hand, and they were making a similar product and said, hey, we're interested in that piece of equipment. And they brought it over. I had an operator who was like, you're telling me that I don't have to manually weld these anymore and I can run them through here? Oh, hell yeah. And then I had engineering who was also passionate about it. Now 120 assemblies a day running through the same equipment with very little change to the equipment. So it really comes down to that. And it was a, someone said we've done it this way forever versus someone else looked at it as an opportunity to learn something. And then the MIG welder at the customer, he went from being a MIG welder. Now he went to some Allen Bradley training. He went to some FANUC robot training. He's able to troubleshoot, but also if a new product gets added to the line, he's able to go in there and, let's say, like add the mixture, the recipe or whatever to the system and run it no problem. So it's definitely important to make sure that everyone's signed on board with what we're trying to do up front, down to the operator levels. And one way that I found really helps us to, let's say, get them on board early on is to involve them early on. When we have these meetings and we have lineups, how often do you see you walk a line and engineering guys are kind of like, oh, no, don't talk to the operators. They're going to whatever. But the operators are the one who use it every day. They're, some of them may be causing you problems, but I think generally speaking, they want their job to be easier if they can, and they're looking for opportunities to come up. So involving the operators has definitely helped us. So,
yeah, 100%. I think at the end of the day, even if the manager is the one that signs off on the purchase order or the contract, unless the people on the ground are using it, it doesn't successfully go live. So I'll kind of shift a little bit in terms of perspective. So when we speak with certain decision makers, especially those who are very pro science fiction, read a lot of stuff online, the expectations of what robots can do tends to be a little bit far-fetched in some cases, where the idea is that if I get a bot, I'm going to put it on the field and it's going to run immediately from like T0. But as you would know, and I think as we have experienced as well, it's very rarely the case. And like we spoke about earlier, there's a lot of things to kind of consider before kind of implementing that. So from that perspective, do you see a lot of mismatch in what people expect a robot, not expect, more like imagine a robot can do, and then kind of bringing them down to reality to say this is what actually can be done? Do you kind of come across that very often?
Yeah, definitely. So, putting robotics and automation in, it's as much of a culture change as it is a product or a process change, right? So it's kind of like once that equipment goes online in the plant, buckle up because your set of challenges is different. You're not worried about the employee calling off now, but again, back to that crap in, crap out. If you don't have consistency coming into the cell in these applications where there's no vision or there's no course correction for the robot is going to do the same thing repeatedly every time consistently, right? So if you're presenting parts to the robot inconsistently, you're going to have a problem. And if you're presenting parts to the robot that are out of spec, you're going to have a problem. And so I think people needed to now, now that we've been in this, let's say this robot vision push has been, we're probably 10 years into this now, where the technology's come a long way, the cost has come down a lot, so we're able to do these more. But going back 5 years ago, someone's like, well, can it just know where to go and pick the part? And it was like, well, yeah, but you guys didn't have budget for that, or you guys didn't want those cameras, or we suggested that, but you thought you would be able to present it to us consistently. So there's been a lot of, especially let's call them like the finance type folks, who are saying, oh, no, you should be able to put this in and hit the green button and it just runs, right? So we've seen that. There's another layer too, which is if you have a clean room and you want to put a robot in a clean room to do a pick and place, okay, no problem. But if you want to do a pick and place inside of a weld cell or something like that, where there's contaminants and dust and whatever, and you expect that the maintenance should be the same for both applications, it's not. The weld cell's going to clog up the robot, or we need additional guarding on the tooling, and the tooling's getting beat up quicker, and to say it should just run. Well, did you guys lubricate? Did you guys clean the contaminants off of the tooling or the robot? Did you guys do your PMs? I think a lot of the, like what we were saying earlier, a lot of the unseen costs of automation kind of come crawling out of the woodwork, and then companies are getting upset with the integrator because they didn't consider some additional factors that go into putting these automation systems in.
Yeah, for sure. I think, like you rightly pointed out, when people start with a very far-fetched expectation without really knowing what works, and then they see something else on the facility floor, it takes a bit of effort to kind of get them to accept what it really means it takes to run automation successfully.
So
we spoke about a few things. I think things like serviceability, productivity, how we approach the design itself. So when you speak with customers in the US, especially as manufacturers, it doesn't have to be automotive, it could be like the other ones as well. When they eventually decide who to go with as a vendor, as a partner of automation, what has been generally the most important factor that decides I go with this vendor over another one?
A lot of customers have legacy equipment in their plant, right? So maybe they have a AGV that's 15 years old that's still running around a magnet strip doing something, right? And now you want to introduce AMRs in there. So from a safety standpoint, you're worried about operator collisions, but now we're also worried about robot to robot collisions or AMR to AGV collisions, those kind of things. So I think having like the Botsync software as part of our portfolio really helps that, because it's not just putting a new cell in and whatever happens inside the four walls of our guarding, we're good. Safety expands beyond that. What happens if a robot is placing something into a zone where there's some piece of equipment that maybe we didn't design, or an AMR's got to drive through an area with equipment that we didn't integrate? So how do we make sure that we're talking to that equipment, putting interlocks in where required, and we're aware at least of what's around the cell, right? So I think that's a really important factor for a lot of people is they're scared, especially some of these guys that have equipment that's maybe been running for 20 years, 25 years. It's not a normal PLC. They got, 100 relays in a cabinet running this thing. So you better not take that piece of equipment down, because there's only one guy who knows how to service it, and he's 70 years old. So those situations do exist. So being able to prove or maybe sell your customer that they're confident that you can put what you need to put in there, and then also give them a platform where they can look and see how the handshaking and interfacing of the legacy equipment with the new equipment's happening. And it may not be legacy. It may be, in one cell, SK Robotics won the bid to put AMRs in, but in the cell next door, MIR won the bid. So we got to make sure that if we're driving through the same zones, right, we're talking to each other and not smashing stuff up. And like we always say, like robots are components, fixtures, carts, tooling, end effectors. Those are all components, but the true deliverable, the true value is in the integration. So I use the analogy a lot. It's like a symphony orchestra, right? You have all the different sections, but somewhere there's got to be a conductor making sure that everyone's playing in harmony and rhythm together, and that the music sounds good, which means that everything's running smooth and products flowing down the assembly line, right?
Yeah, very true. I think interoperability has been like a growing, I guess, concern, especially for companies who are automating to a fair degree. And like you said, if it's been running for a while, the last thing they want to do is kind of go in and change anything there. So how do you make systems work alongside that makes a big difference. You spoke about a little bit earlier about how you spent a fair amount of time in India as well. So I'm assuming that it's been exposed to automation and how that runs in India. And based on that experience, we spoke about the fact of integrating with existing systems, integrating with other robots, and then the entire aspect of ensuring operator buy-in. India is a very different market again from the US. How do you see those comparables? Like what was similar? What has been very different when you look at those two markets?
Yeah, I would say that safety is definitely a little bit different over there, right? Our operation in India is AS9100D certified. ATS India Private Limited is the name of our partner in India. And if you look at their facility, it's a world-class manufacturing facility, heavy emphasis on 5S, heavy emphasis on safety. We're making the guys wear closed-toed shoes, safety glasses, all the full works, because we come from that background. We've seen the injuries. We've seen what can happen. Back in the day, you'd walk in there and see guys in sandals and, kind of squinting while they're using a grinder, whatever. So we put a stop to all of that. And so that philosophy that we have in-house right now our culture is, no, safety is important. So when we take that into our automation systems and things like that, we're really putting a big emphasis on that. On the automation side, cost is definitely more of a factor over there, because even if you're able to eliminate, two operators in the United States, the equipment ROI is 10 times faster than if you're able to eliminate two operators in India. So typically what we've seen is if somebody's looking for automation over there, it's not necessarily to eliminate people, it's to improve product consistency and quality. And then do some inspections perhaps and things like that, because you're able to get this industrial labor fairly cheap, right? And so you're not going to put a robot in to replace a man and expect it to pay for itself in 2 years, right? So
very true. We've also realized that even across the Southeast Asian landscape and India, adding to that, the perspective which is selling automation on is very different country to country. Like you said, it's productivity, safety in one, it could be innovation in another. It could purely be a global HQ pushing down on the local factory to upgrade itself into a future-ready factory. But yeah, I think it's a very interesting kind of different factors. So maybe to round things off, application engineering, especially what you're doing now, is a very interesting space, because I'm assuming that it's not just mechanical engineering. You need to understand people, you need to understand process, you need to understand software, understand electrical systems, mechanical systems. So on a day-to-day basis, what does that look like? What kind of keeps you excited about this job? Second, and I guess for the audience as well, if someone wants to get into this, what is the pathway to get into this kind of a role in a robotics or automation company?
Yeah. So, all right, let me hit the first part. So we have a great owner here at SKI. Okay. So he's put me in a few challenging situations over the years, and I recently kind of thanked him for it, which from an applications engineer, right, you do need to know controls and mechanical. And we do a lot of applications where it's fixturing, right? So it's just a set of machine parts assembled into a fixture, CMM'd, and then delivered, right? So you need to know the machine tooling side as well. So the owner, we had some turnkey systems. This is going back to our early days, and we weren't able to get our controls engineer from India over to the US due to the pandemic. So
Mm.
he's like, I need you to figure this out. So I was kind of forced into the YouTube Alan Bradley college, and I had to write the logic. So thank God for that opportunity. It really clicked a lot of things in my mind, and now I've done quite a few of them. But it's given me a perspective of being able to say, hey, okay, you want this, you want this, you want this. I understand the time in the machining, the assembly, the programming, the robotics piece. So it's given me a good set of background to be able to manage my team. And for me, it's important to have a great team. Like I have a fantastic applications team here in the United States. I have a great team in India as well. I have a really strong mechanical applications team, but I also have manufacturing estimators and a controls guy in India who's able to do that. So, we can't do it all. As a leader of your company, you can't do everything. It's important to have the right team, but as the manager, you better know a little bit about a lot, or at least enough to ask the right questions to make sure that, number one, your customers aren't getting more than what they need, but you're not shorting them either, or shorting yourself. And then you got a proposal now that these guys need something expensive and you missed it during quoting. So having been forced into, let's say, end-to-end machining, assembly, controls, launch, end to end a whole bunch of times on these systems has really worked out. And so one of the things we do is, if we have some machining work and we're slow, I'll actually tell some of the team members, hey, how about you guys go work the floor today? How about you try this? How about you build this control panel?
Mm-hmm.
So I'm taking project engineers and applications engineers and putting them onto panel builds or bridge ports and letting them work in welding perhaps. And when someone shows even a spark of interest, hey, can I try welding that? We're like, absolutely, go weld. It's important you know how to do that, right? So that's one. The guys coming right out of college, nobody's going to college for applications engineering. Someone's going to college for mechanical engineering, which usually has an emphasis on physics and math. So they're able to do, like, if you need to do some FEA, they're good at understanding how to put loads on a structure and make sure that, the frame's not going to bend or whatever. But if you need these guys to say, like, here's a stack of drawings, how would you process these machine components? You're going to have a hard time with that. So trying to find a balance between skilled trades guys who are able to kind of fill that gap, but also bring that knowledge into the engineering guys, because they're capable of learning. They just need to be shown. But when I'm hiring guys, what I'm looking for is if somebody says, like, yeah, I like working on cars. Okay, instantly, now I don't have to tell you what a cylinder head is or a torque converter. You already know what that is, and possibly know the inner workings of it, especially if they're like a real gearhead type guy. So I like asking questions about what's their hobbies. Just because somebody got a 4.0 in engineering school, to me, doesn't necessarily mean that they're going to walk in the door with any sort of real world knowledge, right? And that's what we've found over the years. And so when I'm hiring, especially like one guy recently came in and we were like, hey, our multimeter died. We're doing a debug. The multimeter just died. And one guy's like, I got one in my car. And he was a recent hire. And we're like, oh, okay, cool. Why do you have that? He's like, so I can work on my stuff. What do you mean? And it was like, okay, good. Like, good answer. You know what I mean? So that definitely kind of impressed us, right? Being able to see somebody with the willingness to try and learn and do some things, right? So
Yeah, absolutely. I think similar for us. I mean, we always find it, especially at the start when we hire a team, a lot of our engineers are people who could build an entire board on their own, which means they had a little bit of design knowledge, a little bit of electrical knowledge, a little bit of software understanding with maybe one area of specialty, but enough to be able to put together an entire board from scratch on their own. And it's always a lot easier to kind of scale from there, because if something goes wrong, you don't have to depend on just one person, but you have an entire team of generalists who can kind of get their hands dirty and get things done. I think with that, I think that's what we wanted to cover today, Eric. It was a pleasure having you. Unfortunately, we couldn't do it in person, but next time maybe we could do it in person.
Next time, yeah.
Yes.
Or maybe next time in Singapore. So
for sure, always welcome.